Hello everyone, in this series of videos we are going to learn about simple mathematical functions. So let's just begin with trigonometric functions. We will cover all trigonometry in 3 or 4 parts, and this is going to be part 1 of those. So let's begin with sin x. The proper definition of sine of an angle can be given as follows. The sine of an acute angle is defined in the context of a right triangle. For the specified angle, it is the ratio of the length of the side that is opposite that angle to the length of the longest side of the triangle. It can be better understood diagrammatically. Let us take a triangle ABC. In this triangle, AB is base and BC is perpendicular with respect to angle x. So by definition, sin x is equal to perpendicular over hypotenuse, which gives sin x is equal to BC over AC. The value of sin x varies with x. In this table, we have some commonly used angles and their sine values, and I have also provided an easy way to remember these. Now we take a look at the graph of sin x. Here we can make 3 conclusions. Number 1. Sin x is a periodic function with period equal to 2 pi. Number 2. The minimum and maximum value of sin x are plus 1 and minus 1. And number 3. Sin is an odd function, that is sin of minus x is equal to minus sin x. Unit circle representation of sin x. All trigonometric functions can be defined related to a unit circle. A unit circle is a circle with radius equal to 1 unit. Now in the circle, O is the center and OA is the radius, which is equal to 1 unit. Then by definition, sin x is equal to perpendicular over hypotenuse, which is equal to AC over AO, which gives sin x is equal to AC, as AO equal to 1. So we see that sin can be defined as the perpendicular drawn from the point of intersection of the radius with circumference of unit circle to the horizontal base. Series definition of sin x. Sine of any algebraic value can be obtained using infinite series x minus x raised to power 3 over 3 factorial plus x raised to power 5 over 5 factorial minus x raised to power 7 over 7 factorial plus and so on up to infinity. Sin x in terms of exponential function can be given as shown. Now we take a look at the graph of different sine functions. Here we have the graph of sin x and sin 2x. We can see both functions have same maximum and minimum value, but their period is different, with period of sin 2x is equal to half of sin x, that is pi. Similarly for sin 3x, minimum and maximum value is same, but period is 1/3 of sin x, that is 2 pi by 3. Here we have the graph of sin x, 2 sin x and 3 sin x. We can see that multiplying a sine function by a numerical value only increases its maximum and minimum value. Now we take a look at the graph of sin square x, sin cube x and sin raised to power 4x. Here we can see, number 1, only odd powers of sine can have negative values, and number 2, the peaks become narrower for higher powers of sin x, as only those values of sin x which are near plus minus 1 are significant, as all other values result in insignificantly small values when raised to some higher power. X sin x. It is a function which possesses properties of both functions x and sin x. Like function x, it also increases in going away from origin, and like sin x, it has oscillatory nature as well. Finally, it is an even function as x and sin x are both odd functions, and their product result in an even function. Sin x over x. Here x dominates over sin x for larger values, and oscillatory nature reduces in going away from origin. Now we are done with sin x, so we take a look at cos x. The cosine of an acute angle is defined as the ratio of the length of the side that is adjacent that angle to the length of the longest side of the triangle. Now we take a look at the diagram. Here cos of angle x is equal to base over hypotenuse, which gives cos x is equal to AB over AC. Here we have values of cos x. These can be obtained from sine values, writing them in reverse order from pi by 2 to 0. Graph of cos x. Just like sin x, its minimum and maximum value are plus 1 and minus 1 and period 2 pi, but it is an even function around the origin. Unit circle representation of cos x. Just like sin x, here we have a unit circle with OA as radius. Now cos x is equal to OC over OA, which gives cos x is equal to OC. That is, cos x can be defined as the projection of the radius onto the base. Cos x can be expanded into an infinite series, just like sin x, as shown here. Here we have the graph of cos x, cos 2x and cos 3x. Just like sin x, increasing multiple of x reduces the period of functions here as well. Here we have the graphs of cos x, 2 cos x and 3 cos x, which all have different amplitudes but same period. Now we take a look at the graph of various powers of cos function, which is similar to sine function but with change in position of the peaks. X cos x. The plot of x cos x is similar to x sin x, with the slight difference of it being an odd function about the origin. Cos x over x. It is also an odd function, with its value approaching plus minus infinity as x approaches 0. It is due to cos x approaching to 1 at x approaching 0. Some other sine and cosine functions. Here we have the graph of sin x cos x and 2 sin x cos x. Here we can see 2 sin x cos x is equal to sin 2x, as its graph is same as sin 2x. Now we take a look at the graph of sin x plus cos x and sin square x plus cos square x. From this graph, we can see that value of sin square x plus cos square x is always 1. So we get the identity sin square x plus cos square x equal to 1. Finally, we are done with sine and cosine functions. Thanks for watching everyone. If you liked this video, please do like and subscribe my channel for more videos.